So today I am going to discuss about the periodic table, which is modern periodic table. So now I'm going to discuss about the modern periodic table. Modern periodic table. And what does it state? A modern periodic table states that the physical and I'm sorry, and chemical properties of an element is dependent upon the the physical and chemical property are dependent upon an atomic number, right? Atomic number, not atomic mass number. Atomic number, not atomic mass. Because previously, when with the other discoveries, also because the periodic table is not an accident discovery, but it has been done by series of the experiments like Dobner series and a lot of hard work and dedication. After hard work and dedication, the modern periodic table was you know was actually achieved, right? So it depends on upon atomic number, not on atomic mass. And one of the most biggest contribution was given by one of the scientists known as not scientist but Henry Moseley. Now I'm going to call it a scientist, of course. So one of the biggest contribution was given by Henry Moseley. According to him, that the square root of frequency is directly proportional to the atomic number, which is represented by Z. He performed an experiment like when he took the anode ray and he passed the rays on this anode rays. So he noticed that the rays so produced depend upon the positive charge present on the plate, right? And it varies with the positive charge present on the plate. According to him, the properties vary. So he came to know that the physical and chemical property of an element is not dependent upon its atomic mass but upon the atomic number. So it was one of the the biggest discovery in periodic table, right? Like if the modern periodic table is based upon atomic number, not atomic mass, right? So we're gonna raise it. So we're gonna move a bit. Like I'm gonna move the bit so we can proceed further. Okay, I'm gonna read it. It's almost done. Yeah, I mean it's pretty done. Okay. So according to him, modern periodic table is just based upon atomic number. Then what he did, he discovered that. Let me just move a bit. Yeah, it's fine. Then what discovery was made by him? The next discovery was now we're going to discuss about the periodic table. We know that the periodic table has vertical rows. First of all, we're gonna differentiate, right? Periodic table. Periodic table. If we talk about periodic table, we're going to divide it into two blocks. This is something like this. Horizontal rows and vertical columns. Horizontal rows, horizontal horizontal rows and vertical column. Vertical column, it is based upon horizontal rows and vertical column, right? If we talk about, firstly we're going to talk about period, which is horizontal rows, right? Vertical column. So if we talk about period, the shell number indicates the period, right? So we have 7 periods in a period indicate the shell number, right? So we have 7 periods, right? We have 7 periods. If we talk about the first period, it is the shortest period. The more I'll speak, but I'll write less because we don't have a space here, so they're gonna write each and everything that I'm speaking at the moment, right? So first period is K-shell, and it has only two elements. I'm going to write like this. This is a short form of element I'm writing here. Second is L, right? And it has 8 electrons. Oh, not 8 electrons, but 8 elements. It is also a short period. Then we have third also period also have 8 elements, right? Then we have 4. It has 18, fourth period. Like this is short. I'm gonna write a short form, short, short, short. But this period, which has 18 electron, is not a short period. Low is though it is a shortest. We're gonna call it as shortest. Short word is not resembling with the other given, so we have to create a differentiation with emphasis, right? So this is shortest. This is long. Then we have fifth period. It's a fifth period. I'm gonna write it where I'm gonna write it. Okay, I'm gonna write it here. Fifth period, it has 18 elements again. Now when I talk about sixth period, it has 32 elements. Sixth period, 32 elements. I'm gonna exclude my area. 32 elements, and this is the longest period. This is longest. I'm gonna write like this. This is the longest period, and it includes lengthy side series, right? If we talk about the last, though in some books it is given that it's not in an incomplete period, though sometimes it's given that it is an incomplete period, which is the seventh period. This is anti-side series, okay? Anti-side series, anti-side. So anti-side series, right? So there are basically 7 periods in a periodic table. But if we talk about group, before moving ahead to discuss about the group, let me just give you the concept of how we're gonna find the period of an element as well. So we're gonna remove the each and everything is given here, so that we can get a bit idea about how to find a period with a short period. So, yeah. For a period, let's just take an element. I'm gonna take a grey color again. Sodium. We are taking sodium, right? Sodium has 11 electrons. We're going to write the electronic configuration here. We know that the modern periodic table is based upon atomic number. So that's why we're taking 11 electrons. 1s2, 2s2, 2p2, 1s2, 2s2, 2p6, 3s1. This is completed, right? So as you can see that the last electron has been entered in the third period, right? So this is principal quantum number. The last shell principal quantum number, or highest value of principal quantum number. Highest value of principal quantum number. Highest value of principal quantum number. Value of principal quantum number indicates the period. So here it is present in the third period. So you can take any other element, for example, carbon. It has 6 electrons. You're going to write it as 1s2, 2s2, 2p2. Right? 1s2, 2s2, 2p2. So it is present in the second period. Carbon is present in second period. So now I've gotten an idea that how we're going to find out the period as well. So next video we're going to talk about groups and how to find groups, represented elements, transition element, inner transition, outer transition, and everything about group that we need to discuss here, right? Okay.